At the okay, I'm recording now, but I told you that first on this level you have to make the distance between these two axes more than 50. Can be 54, 55, 60, whatever. But it has to be more than 50 because the minimum distance for a basketball court is 50. And then with the 3D view, you can copy because you have already created all these beams and footings and all that stuff. So you can copy all these, but we don't want this. Okay, so now I think we can copy. Yeah. Okay, how many times? I don't know. At the end, it has to be more than 84. So I don't know how many yeah, how many bays do we need? But if you take a dimension, if you place a dimension from this point to that point, well, now it's 84. It has to be more than 84, so probably we need one more here, okay? So with uh, one more truss, one more column here, then we can have this basketball court. And then we have to do the same with the footings. So I told you that we have to move this up to level -10 or whatever. Okay, so we can make this -10. That would be level -10. Yes. And finally, we have to create a level 0. So if we move it 10, yeah, so that would be level 0 again. Okay, so this is the starting point, and now you have to create all the elements that we did last time. Okay, so we need a other concrete structure. We need the retaining walls, a concrete structure underground or on the basement. But I want you to use this file because yeah, we did these truss systems and we created all these beam systems, and this is one of the requirements. Because what do we want to do now? Well, I want you to learn how to work with these framing systems, and at the same time, you're learning something about Revit, but the most important thing is that you should learn something about construction. So today we will speak uh, about how to get rid of water. This is one of the most important things in architecture, not only in steel structures, but in every different structure. And since we are having all these, well, as I have copied this, they are not meeting, but okay, you can fix that. Anyway, that's the way to start. And then you have to create the retaining wall, the 0 level, the first floor, and then follow the steps that we made in the last lesson. And then you can end up having this. Okay, but this is the starting point. This is where we finished last time. We started creating the envelope of the building. We wanted to see this steel structure, this exposed structure outside, because inside we have to uh, solve the thermal breach. So we need to continue the thermal insulation. Okay, and we will do this by creating parts. And then I showed you how to divide parts here. You can do that in walls, in roofs, in floors. It's very convenient dividing this or knowing how to divide these parts because you can add more details to your design. Okay, but that's the starting point. What are we going to do today? Okay, this is what I did the first day, and now I find out that I don't like it, so I have to change it. I'll do it. Why don't I like it? Well, if you see in these two elements, okay, so this element here is sloping through or towards the building. This is a common mistake, okay? We are doing this, and if it rains, all the water will go there. Is it, can we do this? Yeah, we can do anything. But I think that will be a weak point when it comes to water leaks or infiltration. Here, there will be a weak point because we are forcing water to go that way. It's more intelligent to force the water to go outside, to go outwards. So we have to move the water down and out. Here we are moving the water down and in. So because we are forcing the water to go towards the building. We can solve this. We can use more waterproof elements here, or we can protect this wall. But this is a design flaw. So why, if I can solve this, why do I need a mistake? Like, it's not a mistake, but it will cause problems in the future. Maybe not today, maybe not tomorrow, but in 20 years there will be a wonderful water leak here, and then you will need maintenance, and you will have to spend money on this, and the owner would say, who was that architect? Okay, so at least we will make a lot of mistakes in our life, but try to prevent them. So I don't like this, and I'm going to do something fun here because this is like the roof. So this is not a floor, so it's just a roof. We have an overhang here. Okay, so this is just a roof for this floor. Uh, I'm going to delete this. I'm going to create another pattern for this roof. I will use again these tilted beams, and I will create again the beam system, so you can remember what we did. But now I will fix the water issue that I have here. Um, so when you are doing this, you can do whatever you feel like. I mean, you can use the same pattern I'm using, or you can use a different one. But if I analyze this from the water perspective, this cannot happen. Okay, so there can't be slopes towards the building itself. So the water has to imagine that you have a drop of water here. What does this drop of water do? It goes that way. Okay, that's fine. But if it goes that way, if it goes towards the building, this is wrong. So it cannot happen. Okay. Oh, but before, I wanted to show you this. This is a webinar that is going to take place on Thursday, March the 18th. Okay, day after tomorrow. I think it's interesting because first, it's for free. Okay, so it's a free 30-minute webinar. So it's for free, and it's short, 30 minutes. We all can spend 30 minutes looking at or watching what these guys are doing. It's interesting because it's a multi-framing with model groups in Revit. I think it's timber oriented because they have wood framing and they have metal framing. I think they are going to talk about wood framing on Thursday. Maybe they will speak about metal framing. Those are those guys, this company, AgaCAD, they are creating like plugins or Revit extensions. Okay, so they have created this module. I think it's not for free, or there will be a trial or free trial version. But eventually, if you want to use this module, probably you will have to pay for it. But at least attending this free seminar or webinar, I think it's good because we get to know if it's interesting or not. Okay, so I'm going to attend, and I'm going to post the link to this in the chat. Where is the chat? Here. Okay. You only, it's for free. You only have to subscribe or register with your email, and then you have to sign in, and well, it takes a couple of minutes, and then you can attend on March the 18th. What is the time? That's interesting. There are two times. We have the Central European season or the US Central season. So it's the US Central from 10 to 10:30. It is, so here it's 1 hour more. So it would be from 11 to 11:30 in the Eastern Coast, I think. I'm not used to. Because if you attend this one, it's 10 a.m. in Central European is like 4 a.m. here or 5 a.m. here. So you can register for this one. I think it's more convenient. And your hosts, the hosts are all these guys, Donatas Axomitas, Gintaris Axomitas, the Axomitas brothers, and Tautuidas Maslauskas. I think they are from Lithuania with this, and the host is Povilas Indriunas. Yeah, I think they are Lithuanian, but that's fine. But apparently it makes sense because I'm sure that they have created modules. We are doing something like this, but we are creating all these elements one by one, and it takes time. I think it's good for learning, but I think they have created like a plugin or something to create this kind of modules with parameters. So you can define how many stats, how many horizontal elements, how many windows, the size of window. So you type all this and you will end up having these modules, and then you can connect all, or you can insert all these modules. I think it's interesting in this area of the country because in residential construction, in some commercial construction, well, you are using this kind of wood frame. Okay, so if you have a module or you have an extension that helps you create these kind of things, I think it will help you in your professional career. Okay, yeah, so it looks interesting. Um, so again, it's for free. If you have time on Thursday from 11 to 11:30 to attend this seminar, I think it will be great. Okay. So let's start with this. I told you that I don't like this. I'm going to delete what I did and I'm going to do it again. Not a big deal. Okay. And I think I extended this column. Yeah, it has a top offset. So let's start from 0. And what I'm going to do now, well, I'm going to continue this beam here, as you can see. But I want to create a profile. It's not going to be a horizontal beam as this one or this one. Okay, so I'm going to create. Oh, and another interesting thing. When I created that beam, I just it's a continuous beam from this point to that point, but I want this beam to be not continuous. So I will create an element here and then I'll copy. So what is that level? It's level 24. So I'll open level 24. Yes, so I want to go this way. So you have to go to structure. Oh, and that's something some of you asked me, why can't I see my, if I have created walls, for example, on level 12, do I have walls? Okay. On level 0, I have walls. This is a wall. But you only can see the walls if you're in the architectural discipline. If you're in the structural discipline, the walls don't show up, or some of the walls won't show up. Those are structural walls, because if we go to structure, we do have structural walls. But if you have created those walls with architecture, with the architecture wall template, they won't show up. Okay. So if we're working with the structures, it's good using the structural discipline. But if we are working with walls, it's good to switch to architectural design. So the good thing in Revit is that now we can switch easily from structural, mechanical. A few versions ago, this wasn't possible. Okay, so if we are working with architectural, all the walls are here. What I was doing, level 24. So I want to create this beam system. So I have to go to structure, beam, and well, this is you have to select this one, and we have to work with the same beam that this is the W310 38/7. It doesn't matter, this is the beam you are using, but it would be great if we can create the same beam here. Beam. Okay, so this is a W310 38.7. So I want to be on level 24. And then on level 24, I'm going to create this, but I don't want to go all the way. No, I want to create just a single beam because I will change the starting and the end point of these beams. You can always copy multiple. Okay, so now we have all these beams here. There are different elements. You see that this is a continuous beam. We can do either way, but what I want to do now, it requires different elements, not a continuous one. Okay, now on the 3D, we have the beam here. And well, I'm going to work with these elements, and I'm going to change. Okay. I think. Okay, good. Do not copy this element. It's better if we create. Yeah, because yeah, you can copy them if they are all the same. If they are all the same beams, but when you copy, then you have to unpin or ungroup all these elements. So I think we will start earlier. We will start. Yeah, we will finish if we create single beams. There you go. Okay, so now we have the same thing, but if you select this, you have an element, and then you can edit this element. If you copy, you have to ungroup it, and then you can edit it. Well, it's the same, but I've done this. So by selecting this beam, I'm going to change the end offset to 1. Okay, so you remember that if we selected the beam, we can change this offset. And now I'm going to create a shape, a symmetrical shape like this. So in this one, I have to change the start level. Now I select this and I change the end. Here, I'm going to change the start and the end because I have 7, 1, 2, 3, 4, 5, 6, 7 base. If you had an even number, you can continue to do this, but if you have an odd number, then we have to do this because otherwise it won't be symmetrical. So this is the starting point, 1. This is the end, 1. And this is the start, 1. Okay, if you look at this, I have created this beam elements. They are not horizontal, just to make something a little more fun. Okay, so there you go. I'm going to try to copy this, but I think I will have to do it again. But let me check if copying this. Okay, and now we're going to copy all these beams that I have just created on that grid from grid G to grid B. Now, can I edit? Yes, I can. Okay, so I'm going to do just the other way around. So if this starts with 1 and ends with 0, so I'm going to start with 0 and I'm going to end with 1. If this one ends with starts with 0 and ends with 1, it's going to be the other way around. 0, 1. Oh, this is 1 and 1, so that would be 0 and 0. This is 1, 0. This is 0, 1. And this is 1, 0. I want to see what I have done. Yes, so this is it. So I have, if this goes from 0 to 1, that one goes from 1 to 0. Okay, so now on the 3D, we see that have the symmetrical shape in this and that. Why? Well, you can try different shapes. I don't mind. The only thing that matters is that the water has to go outwards. That's the only thing that really matters. And if I want to make sure that the water goes out, yeah, I think I'm going to move this downwards. Okay, so I'm going to select all these beams. And I'm going to move all these beams just like 2 feet downwards. Okay, so now we make sure that if we create a beam from this point to that point, it will go out of the building. Okay. So now look at this. It goes from -1 to -2. This goes from -1 to -2. That goes from -1 to -2, and that goes from 0 to 1. Okay, so I have moved everything 1 foot downwards. So we make sure that it will slope always outwards. So now I have to go to level 24 and I have to create the beams in the perpendicular direction. So I go here and here and then there. Okay, so now I have to fix this because this goes from 0 to 0, but this starts in -1. So that has to end -1. There you go. And this one has to start -1. Okay. So now, as you can see, this is going down. It slopes down, and it doesn't affect the building. Um, okay, so now I have to do the same with all the beams here. So in level 24, I can create a beam from this point to that point, and then from this one to that one. And I'm sure that it should work if I copy this. And now I select this one. Okay, it works. So I'm going to copy them. I don't know why it didn't work before, but I think if we copy all these, it will work. But now we have to adjust the height of all these elements. As you can see, this doesn't start here, so it should start 1 foot up, and it should end 2 feet down. Yep, and that one starts 2 feet down. Come on, yep. Okay, and now I have to do the same with the rest of the beams. I think this has to go 1 foot. The end is 1 foot down, and the start is 1 foot down. And this is 2, not the end. It's -2. It starts -2. This is 2, or okay. And the end, this has to start 1 foot up. There you go. So this one, I think it's the same. So this is 1 up, -2 down. This is -2 down. And this one is -1 down. It starts -1. And we only have 2 more left. That starts 1 up, -2. That starts -2. And that ends -1. And that starts -1. Okay. So now everything makes sense, because a drop of water falling here, it always goes outwards, okay? And these beams are always sloping downwards. The slope can be steeper or less, but it's always downwards. So we make sure that we don't have any issue with water there. Now we only have to create the beams here. And to do this, okay, that's interesting. Okay, let's go to level 24, and we need a beam here. And now we can copy that beam many times. you go. And then on the 3D view, well, we don't have to adjust the height of this beam because it's always it's always the same. Okay, so now this beam is horizontal, but the roof is not horizontal though. Okay, why am I doing this? I'm going to use the mass modeling to create the roof. Okay, because this roof, as you can see, it's not flat, and we cannot create a slope. So we are going to use the mass modeling. We did this on the second exercise, on the second class work, when we were creating those weird shapes, and then we were connecting this. So we are going to create this roof using this massing and site. Okay, I want to combine different things that we have already learned on this, because we can create steel structures, but we can change from the architectural to the structural discipline, and then we can change from the usual modeling, Revit modeling, to the massing and site. Okay, so I'll mix up different things. Well, there's something I don't like. This is the length of these columns. So I think we have to go 1 foot down. And in this one, we have to go 2 feet down. The top offset is 2 feet down. Okay. So if we select all the columns that have to go 1 foot down, and now I'm selecting all the columns that have to go 2 feet down. Come on. Okay. Well, that looks like a steel structure. And now you remember that we can create the beam. What is this? We can create the beam systems. Okay, so the beam systems, it's always in the structural, in this structural tab. We can create a beam system. We can pick points or pick support, sorry. So we are picking this one and this one and this one and this one. Why do we have this? Yes, I want to discard. So I'm going to create the beam system. I'm going to pick support, but why is this here? And I cannot select this. What if I select? Well, I know there's something wrong with it, but I will fix it later. But that shouldn't happen. When I'm creating beam systems, I should be able to create a beam system. There should be something wrong with the work. Okay, so can we set its grid A? Oh, yeah, I know what's going on. Okay, I set the working plane to grid A, and no, I want to go to level 24. Okay, and then I think I can create the beam system out of support. Yep. There you go. But I want to edit boundary because the beam direction should be the other way around. Okay. And yeah, now I remember that this beam system should be smaller than the other one. So we have the main structure and then we have the other one. So I have to select this, and this is not the wide flange. It will be the 5. Okay, that's better. Okay. Be careful because sometimes depending on the plane, if you set the work plane at the horizontal level, that's fine. But the problem is that I had set the work plane on the grid A. What is grid A? Grid A is this one, the first grid. So everything I'm doing it in this plane. So if I'm creating this beam system, it doesn't work because I'm creating this beam system on the plane that is parallel to grid A, and it doesn't make any sense. I want to create it in a horizontal plane. Okay, so that's why if it doesn't work, make sure that you set that plane a level, and then it will work well. Okay, so now we can keep on creating the beam systems. Okay, I'm going to do it again. Beam system, peak supports, 1, 2, 3, 4. Well, I have to set this on level. Let me set this first on level 24 again. And now I can create a beam system, peak supports, 1, 2, 3, 4. I change the beam direction here. This is the 519. I select click OK, and we've got this. Yeah, so I think I can do it again. Beam system, peak supports, 1, 2, 3, 4. Make sure that 3D is activated here. We change the beam direction. We change the beam system to this 519, and it works. Okay. So now we have to continue with these beam systems. Here, I can create this beam system. Peak supports, 1, 2, 3, 4, 3D. The beam direction, it's the right one. And this is 519, okay? Yeah. Okay, why am I not doing this one? Because I want to show you something that maybe you know or maybe not, I don't know. But okay, let's work with this. You see that the connections between this, well, it's not bad, but it's not good either, because we have a gap, especially when we have non-horizontal elements. You see that there is a gap between the column and the beam. Okay, this is because we haven't connections with steel structures are relevant, because it takes, everything has to be well connected, and it takes a lot of time. It takes a lot of um, man hours. I mean, it takes a lot of effort from people to do this, because we have to cut the profile. We have to adjust the profile of two perpendicular or two connected beams or columns, and it takes a lot of time, and time is money nowadays. Okay, because there was a time in which the manpower wasn't an issue. I'm talking about 50 centuries ago. So you had the slaves, and everybody worked as I know, in old Egypt. I don't know how the the pyramids were built, but I'm sure that the workers were not working there for with as a free will. No, they were forced to do that. Nowadays, thank God, it's not that way. Uh, and what really matters when it comes to the cost of a building is the manpower, is the hours, the amount of people working, and the hours that they are working on site. So we have to reduce this as much as possible. And that's why thinking of these kind of things beforehand help us reduce costs. If we don't think about this, there will be someone trying to figure out how to cut these two profiles and then to weld them or to use bolts to connect these beams together. If we think about it, if we, I mean architects, we think about it beforehand, then everything will be a lot easier. So this is what I want to show you now. For example, if we've got these beams here, okay, so this is the vertical element, and this is now the horizontal element, and there's another horizontal element here. And we have a weird connection here because there's a gap, you see, there's a gap between this and that one. How can we fix it? Okay, when we want, connections are extremely complicated. So let me show you steel structure connections. Okay, so look at this. When we have a lot of beams or columns meeting at a single point, look at this. It's something crazy. And we have to figure out how to do that in Revit, because if we do that in Revit, we will save a lot of time. First, people thinking how to connect these two things, and second, people are working there. As you can see, it's not an easy job because this guy is risking his life. If everything works well and everything is well connected, and you bring the column here and it fits exactly on the same place, everything will go well. If you have to modify something here on site, you are making this guy to work more, and first he's at risk, and second, yes, he's at risk, but because of that he will charge you a lot of money. Okay, so we have to uh, make sure that when we're designing these kind of things, everything is we have put a lot of thought into this detail so that when we are on site, everything fits perfectly. And this is what we are doing now. So now we haven't thought about anything, and we have gaps, and someone has to connect those gaps. Okay, so there are two interesting, well, here you see that we have a structure, and here we have a tab with steel. And with steel, we have different options here. We are going to use today cope and meter. As you see, that works with, yeah, that connects different, especially to different beams or columns and beams. Okay, so we are going to use these two options. So first, I'll show you the meter option. And by the way, we will use this one, the one that creates a 45. If we have two perpendicular beams, we cut these two beams at 45 degrees, and then we have a perfect connection here. How can we do that? Well, it's quite easy because we only have to select this one. We have to select that one, and then we have to go to steel. We select this meter option, and now we have a perfect connection here. You see that we have another element. Okay, so this is the meter element, and we can delete it, and now the beams go to the original position, or we can leave it, and then we have this connection, but this is another object. Okay, so this meter, it works like another object that I can delete or I can keep or whatever. The thing is that, let me delete this column so that we can see what happens. Okay, so you see that now this connection is perfect. I delete this one as well. Okay, so you see that now we have no gaps between these two beams. So the connection is perfect. And we have done this with meter. Okay, so now we have this, and I'm going to show you the other option, the cope option, with this beam. Okay, so you see that we have a gap between this beam here and this column. What if we want to make this connection perfect again? You see that we have two shape handles here. So the first thing we have to do is to extend this beyond the column. Okay, so now we have an intersection here, which is weird. And now we have to connect this and the column itself. So now we select these two things and we select steel cope. And now this connection is perfect between that beam and that column. Okay, so basically there are two options. We have the meter and then we have the cope. The cope doesn't, if we use the a meter here, there will be an angle between the column and that beam, and we don't want an angle. We want just to adapt this column to this element. So we don't want to cut this. So that's the difference between the meter and the cope option. It really makes a difference. I mean, when we have exposed structures and we want to create nice renders, if we don't have these kind of things, it will look weird if we don't have these options here. So if we want to work with exposed structures, we should use these elements. It takes time because we have to do the same. So let's connect this beam to this column. So I have to, first I have to extend this, and then I have to select the beam, the column. I have to select cope. And now it works. We have a perfect connection here, and we don't have any gaps between columns and beams. What happens here? Well, that's quite complicated because here we have 1, 2, 3, 4 elements on the same point at the same point. Okay, we will figure something out. But now I wanted to show you this. If we want to have a nice detail here, apparently we should be using a meter option. So let's do that. 1 and 2. Let's use meter. Okay. Am I happy with this connection? No, I'm not. Okay. Apparently it looks well, but if you zoom in, you see that there's something wrong here. Well, this is not because Revit is not doing well its job. It's because we have a bad design. And we have a bad design because of the angles of these two beams. And we have something wrong because these two elements have two different slopes. So this is a horizontal beam, and this has a slope. And apparently this is quite difficult to fix, or quite difficult thing to fix. So what am I going to do? Okay, I'm going to do it, and I hope you will understand, because putting this into words is it's easy. It's complicated. Sorry, at least for me. So what do we have here? So we have a beam. We have to connect that beam that goes from 0 to -1, or from -1 to 0, and we have to connect this to this beam that goes from 0 to 0. So basically, we don't have a slope here, and we do have a slope there. So it will work well only if we have the same slope in both beams. So how can I create this? If I start at level 1, like this, now I have the same slope. That goes from 0 to 1, and that goes from 1 to 2. But the slope is the same because the beams are the same size. So will it work now? So let's find out. So we select this, still, meter. No, it doesn't work. And level is 0, this is 1. Okay, so no, it's not working. If I had this beam like this is horizontal now, and this is horizontal now. Okay, now, yeah, this connection is perfect because both beams are horizontal. Is it but if you change the starting level to -1, now if you see, this connection is not perfect, and that happens in reality. Okay, so if we don't keep that in mind, we will end up having issues working with these kind of things. So that's pretty easy because we are using Revit, and we want to create a perfect connection here, because otherwise this detail won't be nice if we are working with these kind of structures. Okay, so it's easy. I don't find the right angle. Okay, so let's make this horizontal, and here, yeah, here we have a problem. So we have to make this horizontal as well. There you go. And now this connection is perfect between this beam and that beam, and this connection between this beam and that beam is perfect as well. Do we have issues with water? No, because water goes always outwards, so it's not damaging, because we have created this. This point is higher than this point. So when this point is higher, the water goes from the top to the bottom. Okay. Is there a way to fix this so that we have the same angle? I'm sure there's a way to fix it, but well, we don't have, well, we'd have time, but I'm not going to do it. Probably by next Thursday, I'll find out how to fix this, and how to have the same angle or the same slope in this beam and the other beam. But give me some time. So far we are going to make everything horizontal here. We're going to make this horizontal as well. As you can see, the good thing is that the beam system adapts immediately to what we are doing. And now this one has to go 1 foot up. So that goes from -1 to -2 to -1. I think this should go from -2 to 0. Yep, it worked well. Okay, what's going on here? We can select this one and that one. If we want a perfect connection, we use the meter. So now this connection is perfect. And if we want a perfect connection here, we can extend this one. And I think we can use cope. No, we can't, because these are two, yeah, I see what's going on here. Hmm. Still meter. Okay, you see that, well, here, well, we have created a connection. I created a meter between the column and that beam. And since we have this beam here, it doesn't work. Okay, so we shouldn't do this. Yeah, so here we have to figure out what to do. That's fine, because if this element is too complicated, as you can see here, we can always use, let me see. Okay, this is not a good example. Yeah. Yep. Look at this. This beam is not touching the column here. We have this element, and this is bolted here, and there's a gap between that beam and this column. So those are well connected, but here we don't have this connection. Okay, so with Revit, we find out that here we can have this perfect connection here, but here we need something different. So probably we need to extend this element up to here, and here we need to bolt something in transition. Okay, but with this is high level. But I mean, here if we know this option, at least we can try different ways to connect this, and we can work with the engineers to say, okay, what is easier or what is less costly, doing this or connecting the beam to the column to that beam and then the other one. Okay, so that works perfect when we have things like this. Okay, so this is quite easy because we create the steel, the meter, and this connection is perfect. Okay, what happens if we have four beams or three or four beams meeting at the same point? Okay, so then we have to make perfect connections in one way, or we can try something different. So here, what can I try here? So let me undo. Okay, so here I've got the column and this. Now we have a gap, so this is not acceptable. We need to find a solution for this. What if I extend this, the top offset 0? And what if now I don't want this gap, so I can have a cope between this column and this beam? I can create a cope, and I can have another cope between this column, this beam. Okay, so now these two connections are, well, there's a gap, but they are perfect because they match. And what about this one now? What if I extend this, and now I create a cope between this one and the column? The beam and the column, and now I create a cope. Yeah, I think this is the best option. Don't you agree? But it's complicated. I mean, this is a job itself. You receive this file from the architect, and then you have to figure out how to solve all these things. And the good thing in Revit is that once you have this file, you can submit this, and you can cut the beam with the right length and this element to make a perfect connection with this one. Okay, so as you can see, every single meeting point between different beams, it's a project itself. You have to figure out how to do it, and yeah, it takes time. So I'm not asking you to do this, but at least this one you have to make it a perfect, because this is something that we will see. We won't see this element, or we won't see, but if you are taking renders, this angle is exposed, so this connection has to be perfect. If this element here is not perfect, okay, I can live with that, but at least this should be perfect. Okay, so this is something that when you are working with steel structures, exposed steel structures, it makes a difference, because if people zoom out here, we can say, okay, this guy knows about structures, and he has solved this difficult point with 1, 2, 3, 4 bars. Okay, so we have a solution here, and this detail is not ugly, and this is perfect. And well, so this is one of the things that I wanted to show you today, how to work with these two options, the cope and the meter. When we're working with exposed steel structures, it's relevant. Second, I want to show you how to work with a roof here, okay? Because this is the structure, but now we need a roof. So we need a roof with this shape. And well, we cannot create a flat roof, or we cannot have a roof with a slope, because we have different slopes. In this L beam here, it's sloping in this direction. In the other one, is sloping in this direction. This is a tilted beam, but this is horizontal. Okay, so it's a challenge how we create a roof here. So this is what I'm going to do now. First, I think there's a beam system that is missing here. So I'm going to go to structure, beam system. Let's create 1, 2, 3, and 4. The beam direction is this one. And yeah. Okay, so we are going to create a roof here, and then another roof there, and then you will have to have different roofs. Well, you can mirror because this is symmetrical, but at least these first two roofs, we have to, okay. So the only way I know, maybe there are other ways, but if I had to do that, I would use the massing inside, the in-place mass. Well, I did this before. There you go. So massing, in-place mass. Okay. And now you know that this is not easy. And we have to follow a procedure, because otherwise we won't be able to do that. I'm going to use this option here. Well, first we have to set the plane. So here we have, okay, before doing this, let's analyze the building. We are going to work with this grid here, and this grid there. Okay, so it's grid A, B, and D. We don't have anything on grid C. Okay, so we are going to work with three lines, and then we are going to connect these three lines, the line on grid A, the line on grid B, and the line on grid D with the massing and modeling. Okay, so we are going to work with A, B, and D. So let's go back here. If I go to massing and site, in place mass, okay, first I have to set the plane. So what is the first, it's not level, whatever, it has to be grade A, grid A. And I'm going to use this tool here, the pick lines. If we are working with the horizontal, with the structural template, each structural element has a line here. I don't know if you get to see that we can select this line. Okay, now it's selected because this is the structural element, or this is the structural line for this beam. So I'm going to select this one, that it's on grid A, but that one would be on grid B. So I have to select grid B. And now you see that we have another structural line here. There you go. And finally, I have to go to grid D, and there's another structural line there. Okay, so I have selected 1, 2, 3 different lines in 3 different placement planes. So we have grid A, grid B, and grid D. Now I have to select modify, and I select 1, 2, and 3. I create a solid form, and I hope it works. Well, it has worked, but not in the way I wanted. So I cancel this mass. Okay, probably it's an issue with the reference planes. So I'll do it again. Okay, I'm going to work with massing and site, in place mass. Okay, first set the plane on grid. I'm going to start with grid D now. I pick lines. I have to pick this line here. Okay, now I have to work with set plane grid B here, and now I have to set plane grid A, and I have to pick this point. Now I select modify, and I pick 1, 2, 3. I create a solid form, and does it work? No. Well, it doesn't work. Yeah, because now I see what happens. Yep. Okay. It has created like a curved element here, you see. So that line goes from this point, but it's not a straight line. Is there a way to fix this? No. Let me check this one and that one. Let's create a solid form. Okay, with this one, it works well. So apparently, can I select now this line and this line and create a solid form? Yes, I can. Okay, so I have to do it in 2 steps. First, I have to create this one, and then I have to create the other one. And then I finish mass. And I do have a mass here. If we select everything and then we filter and we create only mass. Okay, so this is the element I have created. I'm going to do it again, don't worry. The good thing here is that, as you know, we can turn this mass into a roof. Okay, so we can create a roof. So we can go to architecture. We can go to a roof. No, to roof. Roof. Yeah. So this is a generic roof. I'm going to create a type. And what roof do I want here? So I want to edit the structure. So I'm going to create here. I think there was like a metal deck. Yep, I can create a metal deck. Okay, the thickness. This is just a roof, so nobody's stepping on that roof. So the thickness can be much lower, so it can be something very thin. Let's say 6 inches, six. Yeah, let's say 4. And then we need to insert. We can have, it's not a structural, we can have a thermal layer. So let's work with a rigid insulation. The thickness, let's try 4 inches more. And finally, I'm going to create a finish made of aluminum. And this is something very thin, let's say 1/2 inch. Okay, my mistake, I didn't change the name of the, no. Well, let me do. Well, I have to create a roof because otherwise I'll lose the. Okay, so I'm creating again the this roof shape with the mass modeling. So let's do it again. Massing inside, in place mass. Well, I had already created the mass here, so I'm going to delete the mass that I created. Delete, and I'm going to start. In place mass. First, I have to set the plane on grid A. Then I have to select this line here. Then I have to set this on grid B. And I have to select this element there. Then I have to set this on grid D. And I select this here. And now I modify and I can select this one and that one, create a solid form. So this is not what I wanted. I'm going to do it again. Massing inside, in place. First grid D, pick lines. I'm going to select this line. second reference plane, grid P, and I'm going to select this line. Finally, grid A, and I select this line. Okay, and now I modify. I select first this one, second that one, solid form, yes. And now I select this one, second that one, and solid form. Good. Now I finish math. Okay, I'm going to do it again with the second, with this shape here. So I'll do it again. Massing inside, in place mass. Okay. So first I have to set the plane. I'll start with grid D. I pick lines. I pick this line. Then I have to set grid B here. And finally, I have to set grid A, and I pick this line. Now I have to pick the first and the second line. I can create a solid form, and then I pick the second and the third line, and I can create another solid form. Okay, and I finish math. Okay, and finally, I can go to massing inside. I can create a roof by face. Well, first, I would create a single roof, edit type, and here, well, before doing that I'm going to see if that works. Okay, so I select, make sure that you select the mass, or use, and then you create roof. There you go. Okay, so now we have a roof here. If you select all these entities, we filter, we have a mass, we have structural framing, and we have the roof. So just select the roof, and now we can edit type. So I was going to create a structure which is metal deck. Okay, 4 inches. You go. The second go up. That will be the rigid insulation. Okay, 4 inches. And finally, we can have asphalt shingles, but I think it's more, this is, by the way, this is thermal, and why is it not a rigid insulation? And I wanted to create here aluminum because I like it more. Aluminum. And this is going to be 1/2 inch. Okay. And okay. And the thing is that now the roof that we have created is going downwards. I want to do the other way around. I want to move this roof up so that I can see the beam systems from below. Then I can select roofs, apply. Okay, and then I have to move this, the level offset. This is on level 36, but I have to go, if I have 4, it's 8.5 inches. 8.5 inches. There you go. Okay. It took time, but it's worth it because now I have the beam system, the roof, and now I can apply this roof, create roof to all the masses that I have created. And now I only have to select the roofs. I am. Okay, now I filter, I select the roofs, I move this 8.5 inches, 8.5, and there you go. It takes effort. But I'm happy with this because I see this connection, and this connection is perfect because I have used the meter option with the steel, and now you can see that this corner is perfect. If there are corners that are not perfect here, doesn't matter because I'm not watching at them. But I think now, if we are on level 24, this is the roof. If I create a camera, um, well, it's not level 24, it's level 12. So let's say that this is 15 and 15. Yep. Okay, so this is the roof, but I can see the beam system underneath the roof. This is open, so I see the sky here, but yeah, I like it. And this is the roof. Yeah, this is the roof. Okay, I think we are done today.